And coming up is the presentation by Shri Nirdosh Gupta, Joint Chief Electrical Engineer at Uttar Pradesh Metro Rail Corporation Limited, UPMRC. Shri Nirdosh Gupta is Deputy Head of the Department of Electrification of Metro Projects at UP Metro Corporation. He has been instrumental in completing the electrification work of Lucknow Metro in time, which fetched Lucknow Metro one of the fastest built metro projects in India. He is an officer belonging to the Indian Railway Service, Ministry of Railways, which manages the fourth largest railway network in the world by size, transporting 9.1 billion passengers and over 1.1 billion tons of freight annually. He has in-depth knowledge of the complete cycle of metro projects from concept to operation and a specialism of design, commissioning, interface of traction system. And over to you, sir, for your presentation.
Hello everyone, I am Nirdosh Gupta, an officer of Indian Railways, currently deputation with UP Metro Rail Corporation. I am responsible for traction and power supply works of Kanpur Metro project as well as Agra Metro project. To make any metro project financially viable and sustainable, the O&M cost has to be minimized. The energy cost is around 35 to 40% of total operation and maintenance cost of any typical metro project. So the primary objective of the traction and power supply design is to minimize energy consumption, obviously without affecting its functional requirement. In Kanpur Metro, we have taken various initiatives to reduce the energy consumption. For example, using energy efficient transformers, energy efficient pumps, regenerative braking in lifts, energy efficient air conditioning system, regenerative braking in rolling stock, to name a few. Kanpur Metro is using 750 volt DC third rail bottom collection system. We have used two new technological advancement in traction and power supply system area, which is the first time in India. The first one is using inverter technology for utilizing the braking energy produced by the rolling stock into the auxiliary systems. And the second one is automatic earthing and short circuiting device instead of portable short circuiting device, which will primarily reduce the maintenance time, resulting in reduction in operation and maintenance cost, and also increasing the safety of the maintenance staff. There are various technologies available for utilizing this regenerative energy produced by the rolling stock in DC traction system. The most common is providing onboard brake resistor system installed inside the train. So during braking, the regenerative energy generated by the rolling stock is dissipated in the resistors to keep the voltage within the range. It is a highly inefficient energy system as no energy is recuperated. And further, if the train is in underground section, so the heat generated due to the dissipation of energy will be compensated by the air conditioning system of the underground. So thus increasing the overall energy consumption of the system. Also, the train need to carry dead weight of the brake resistors all the time. So the specific energy consumption of the train will be high. So it is prudent that instead of dissipating this regenerative energy in brake resistors, this energy shall be utilized further. There are various technologies available to restore this energy. One is providing onboard energy storage system inside the train. Another way is to providing wayside energy storage system in the substations. And the latest technology which is available is providing reversible substation using inverters to use this energy in DC traction system. In wayside energy storage system, various types of batteries are used for storage of regenerative energy produced by rolling stock, like lithium-ion batteries or nickel metal halide batteries. In some cases, supercapacitors are also used for storage of this energy. The braking energy is stored from any nearby train while braking, and it is released when a power demand is detected by any nearby train. Like when the train is braking, it is charging the energy storage system, and the train is accelerating, it is discharging the energy storage system. So the key aspect in designing the wayside energy storage system is its placement in the substations. As the energy has to travel each time, like when the train is braking, the energy has to travel from the braking train to the energy storage system. And similarly, when the train is accelerating, the energy has to travel from energy storage system to the accelerating train. So the line transmission losses will be higher if the energy storage system is not placed suitably. For the placement for the placement of Wayside energy storage system, various simulation softwares are available. The benefit of Wayside energy storage system is its ability to minimizing the problems related to voltage sag. Like when the train is accelerating, a sudden voltage dip is observed, which can be taken care of this kind of Wayside energy storage system. And it also reduces the energy consumption. Onboard energy storage system also uses supercapacitors or lithium ion or nickel metal halide batteries for storage of regenerative energy. The only difference is that the system is installed inside the train. So while braking, the energy generated from the rolling stock is stored in the storage system, and it is further utilized when the train is accelerating next time. That means while braking, the train is charging this energy storage system placed inside the train. And while accelerating, the train takes the power from this energy storage system while discharging it. So the main advantage of this energy storage system that it avoids all the line losses. The energy storage system is placed inside the train. So whenever the power requirement is there from the train, it takes power from the energy storage system placed inside the train. But the disadvantage is that this requires a large installation space in each vehicle while designing, which increases the weight of the vehicle. So thus increasing the energy traction consumption by around 2%. So let's discuss another type of another way of utilizing the regenerative energy, which is called as reversible substation with inverter. So in this case, an inverter is connected in anti-parallel with the rectifier to allow reverse power flow from the DC traction substation, which is equipped with uncontrolled rectifier. So when the train is regenerating, the regenerative power flows from the DC network to the inverter, which converts the DC energy into the AC energy, and it is fed back through some transformer or auto transformer to the medium voltage network. And this energy now further can be utilized in auxiliary systems, or it is further converted in DC by using rectifiers, and it is fed back to the another train anywhere in the section which is available. In Kanpur Metro, we are using inverter with auto transformer. The DC energy will be fed to the inverter through inverter breaker and a negative switch which is available in negative cubicle. An inverter cubicle will be having IGBT bridges to convert the DC energy into AC, and DC filters and AC reactors to improve the power quality. In AC coupling cubicle, inverter auto transformer will be placed, which ensures the voltage level to be fed, which is further connected to the medium voltage network. Let's quickly discuss the different recuperative technologies which we have discussed so far, its advantages and disadvantages. In onboard energy storage system, this provides a possibility for catenary free operation. It reduces the voltage drop. It reduces the third rail losses as compared to Wayside ESS and increases its efficiency. The main disadvantage is that the placement of ESS in the vehicle will require a lot of engineering, and it's some safety constraints also there since the system has to be placed on board. Another disadvantage is that it impacts the train operation for any maintenance and repair. The vehicle has to be parked for its repair. Wayside ESS, the advantage is that it indicates the voltage sag. The energy can be utilized by all the vehicles running within the same section, and its maintenance and repair will not impact any train operation since it is placed in the substation. The disadvantage that it increases the overhead line losses because every time when the energy is generated from the rolling stock, it has to be fed back to the substation. And when the train requires the energy will be fed from the substation to the rolling stock. So the line losses will be a little bit higher. Also, analysis is required to choose the sizing of the wayside energy storage and also its location. The advantage of reversible substation is that it provides the possibility to export the energy to the main grid also. Like when the energy is regenerated by the rolling stock, it will be fed to the nearby trains initially. Then through inverters, it can go to the medium voltage network where it can be utilized in the auxiliaries. If the energy is further balanced, then this energy can be fed back to the main grid for utilization of other utilities also. This energy, in case of reversible substation, this energy can be utilized for all the vehicles running in the corridor. Also, the repair and maintenance of on the substation, on the inverter will not impact any train operation because its placement in the substation. There is no passenger safety constraint, so it is not an onboard solution. One of the requirement for placing this reversible substation is that the analysis is needed. In this case, also for choosing the right location and the right sizing. For that, to overcome this problem, various simulation softwares are available, which we can use to find out the maximum regeneration energy points in the section. And to the nearby that location, we can provide these substations. Kanpur Metro project will be the first metro in India on DC traction system, which is using inverter technology for recuperation of regenerative energy. The inverter will definitely reduce the overall energy consumption through grid. We'll be using inverter with auto transformers. And initially, we are proposing 3 inverters in corridor 1 and 1 inverter in corridor 2. As per the simulation results, the payback period is less than 4 years. We have done a cost benefit analysis for this project, and with the headway which is available as per the detailed project report, we have done the simulation that in each case how much energy is available for the utilization. Then as per the number of operations, how much energy is being saved in a day, considering the 16 hours operation of train. We can use around 7,500 units of electricity in a day. So considering 8 rupees per unit, we could save around 60,000 rupees in a day. So annual saving will be around 2.2 crores. So considering the capex cost of the installation of these inverters, 3 inverters, around 7.5 crore, 2.5 crore each. The payback period is around 3.3 years. That means less than 4 years. In DC traction system, portable short circuit devices are used to short circuit the running rail with the third rail to ensure the discharge of current due to the residual voltage, and also to ensure there is no power flow during the maintenance. These devices are bulky and has to be carried by the maintenance staff at the place where maintenance is to be done. For installing these short circuit devices, it is a manual process, which is a safety hazard, and it may risk the maintenance staff to get the electric shock. It increases the maintenance time, and during the emergency breakdown, it is directly affecting the revenue operations. So to overcome these issues in Kanpur Metro, we are using automatic earthing and short circuit device. In case of automatic earthing and short circuit device, these are fixed devices which are installed in the panels at each substations, and it is connected through the cables to the main line. Since it is a motorized device, it can be operated remotely through SCADA, which is supervisory control and data acquisition system. It is very easy to operate. In portable device, no earthing is foreseen, while in case of automatic earthing device, we can do earthing also. Since it is a remote control device, it increases the safety of the maintenance staff. And in case of automatic earthing device, the staff need not to carry the bulky portable short circuit device. So it reduces the time in the maintenance, which result in significant O&M cost. This type of automatic earthing device we are using in Kanpur Metro, which is the first time in India by any DC tracking system. To appreciate the advantage of automatic earthing and short circuit device, let's quickly discuss the maintenance procedure which needs to be followed in case of portable short circuit device. In case of any preventive maintenance or breakdown maintenance, after obtaining the permit to work, staff has to find out where the portable short circuit device is kept. Then they have to carry this bulky device at the place where the maintenance is to be done, which is typically 700 to 800 meters away from the station. Then after reaching at the site, they need to ensure that the system is de-energized. Then they have to fix the portable ESCD. They have to connect it with a third rail, then running rail. After that, only they can start the maintenance activity. While in case of automatic earthing device, they just need to tell the SCADA operator, and the SCADA operator needs to do this on some clicks on the operator console, and we are ready for the maintenance. So it significantly reduces the time and also the manpower. In Kanpur Metro, we are using two types of earthing and short circuit device. One is 4-pole system, which we are using in main line. Another one is 2-pole system, which we are using in depots. In case of the typical 4-pole earthing and short circuit device, we are connecting all the running rails as well as the third rails to a common bus through cables, and which is further earthed to the system. So this is a highly sophisticated system which can be used to reduce a considerable downtime and thus reducing the O&M cost. With this, I would like to thank the audience for patiently listening to me and the sponsors and organizers of this event. Especially, I would like to thank Rail Analysis and Mr. Ashok Goel for giving me this opportunity. I convey my best wishes for this event and all the future events. Thank you.